In an isosceles triangle, like this one here, if I make an angle bisector of this angle at the top of the isosceles triangle between the two congruent sides, this has to come down here and divide this also into equal parts. That's fairly easy to prove. We have a shared side here between these two smaller triangles, and we have an SAS pattern. So that means this, since the triangles are congruent, these two segments must be the same. So when you have an isosceles triangle, if you cut the angle at the top of the triangle in half, the bisector comes down and also cuts the bottom in half. That is not true if the triangle's not isosceles. So here I've basically tried to duplicate this angle here. It's the same angle, and I'm cutting it in half. When I cut this angle in half, since this is no longer isosceles, when this comes down here, it doesn't cut this opposite side into equal parts. In fact, it's quite obvious that this part over here is much longer than this. So this lesson is about how does it divide it up? And it turns out that however long these two sides are, whatever their proportion, the two sides that sort of make up the angle being divided into two parts, these pieces here are in the exact same proportion. I'm not going to prove that in this lesson. I'm reserving that for a future project, but we will learn how to use it to solve some problems. So, in a non-isosceles triangle, an angle bisector divides the opposite side proportionally to the two sides that make up the bisected angle. That's a lot of fancy words. Let me write it in symbols. Let me put some variables on here. If these two lengths are, say, A and B, what I'm saying is the ratio of these two is the same as the ratio of these two pieces down here. So if this is X and Y, X going from here to here, Y the rest of the side, then I'm saying that A over B is the same ratio as X over Y. That's it in a formula. This is it in words. I want to do a couple of examples. I'm going to do a more straightforward one and then a more challenging one. So here's the more straightforward one. Here I have a triangle. I have an angle bisector. I can see that because I've marked these two angles as congruent. There's the tick mark. And then I have these different measurements, and I want to determine what this length is here. So the Angle Bisector Theorem tells me that these two lengths that make up the two sides of the angle that's being bisected, the 15 and the 25, are in the same proportion as these two pieces when we come down here across here. So I can say 15 over 25, that's the two sides that are not being divided, the two sides of the angle. That's the same as 10 over this unknown length. And then I'm going to cross multiply. First I'll reduce. I can divide this top and bottom by 5 to get 3/5. Now I'll cross multiply. So I get 3 times this unknown length here is 10 times 5, which is 50. So that unknown length is 50 over 3. So that's how we would determine this length here. Let's look at a more challenging example where you have to draw your own picture and there are some other difficulties. Second example. In triangle ABC, point D is on BC, so AD bisects angle BAC. Then I give some measurements and ask you to find something. I have to draw what this means. So let's see here. I've got these lengths, AB, BC, AC. AC is the longest. I'm going to try to draw this so it looks somewhat like what it's describing. Is AC is the longest. That's going to be 16. AB is 10. BC is 12. So maybe like that. You don't have to draw a proportional picture in order to solve these problems, but it helps to build intuition. So I have AB is 10, BC is 12, AC is 16. So now let's look at this here. In triangle ABC, there it is, point D is on BC, so D is somewhere on BC over here. So AD, there's AD is going to come across over here, and it's going to bisect angle BAC. So this is why the angle bisector is going to come into play here. I'm going to bisect this angle, and point D is over here on this side. There's point D. So I've bisected this angle, there's D. And now I want to know what is the value of BD and the value of CD. How long is BD? How long is CD? So this is like our previous example now. There's a previous example. I had 15, 25, 10, and an unknown. Here I have 10 and 16, the two sides of the bisected angle that aren't being chopped up. The difficulty now is that this 12, unlike here, our first example, where 10 was one of these little pieces and I needed to figure out the other one, 12 here is the entire length. BC is 12. So I need algebraic names for these two pieces, like I had 10 and an unknown here. So I'm going to use a standard technique from algebra. I'm going to call one of these pieces with the variable. I don't have x anywhere in this picture, so I'm going to let this be x right here. Remembering that 12 is all the way across. I can get rid of this one now. So if 12 is all the way across, and if I say this part of the 12 is x, then I've taken 12 out of this x, so what's left here is 12 minus x. This is a standard algebraic technique when you know a total and you want to give expressions for the two pieces that add up to that total. One of the pieces gets a variable. In this case I chose x. The other is 12 minus x. This is the label point D. This is not part of that, so D is that point. Now I'm ready to set up the proportions for the angle bisector theorem. 10 over 16, those are the two sides that make up the bisected angle. This 10 and 16 are proportional to that piece and that piece, x over 12 minus x. So now I'm going to be cross multiplying to solve for x, and that will let me answer this question. Again, I can reduce this fraction to make my number smaller, dividing these both by 2. I reduce this to 5 over 8. Then I can cross multiply. 5 times 12 minus x is 8 times x. Distributing, I get 16 minus 5x is 8x. I have two terms here. I'm going to put all the x terms on this side, so by adding 5x to both sides, those add away. I get 60 equals 13x. So x is 60 over 13. Yuck, that's a nasty thing. What is that? 13, 39, 52. So this is 4 and 8/13. So looking back at my diagram, I want to figure out what BD and CD are. So apparently BD, which was x, is 4 and 8/13. That's BD. CD is 12 minus x, because this and this have to make 12. 12 minus 4 and 8/13. And 12 minus 4 is 8. I also want to take away 8/13, so I'll get 7 and 5/13 for CD. So that's the length of BD, that's the length of CD in this diagram.